Assalamualaikum warahmatullahi wabarakatuh. To Madam Zarina, my name is Muhammad Fahmi bin Muhammad Noor. My partner for this lab video is Ahmad Akmal bin Azman. So, in this video, we will explain about Chapter 4, Lab 4-1, Redistribution between EIGRP and OSPF. Here is the topology. We have three routers, R1, R2, and R3. So the objective of this lab is to review EIGRP and OSPF configuration, summarize routes in EIGRP, summarize in OSPF at an ABR, redistribute into EIGRP, redistribute into OSPF, and the last one, summarize in OSPF at an ASPR. So the background of this lab is R1 is running EIGRP and R3 is running multi-area OSPF. Our task is to configure redistribution on R2 to enable these two routing protocols to interact and allowing full connectivity between all networks. Step 1. Configure loopbacks and assign addresses. First, I have to configure all loopback interfaces on the three routers and configure the serial interfaces with the IP addresses, bring them up, and set a DC clock rate where appropriate. So this is the command that I already configured at the router 1. So first I configure the interface loopback 0, loopback 48, loopback 49, loopback 50, loopback 51, and loopback 70. The last one I configure the interface for serial 3/0, which I follow as at my GNS. So at the interface S3/0, I also assign the clock rate here. Then this is the command that I already configured at the router 2. So for the interface loopback 0, loopback 100, serial 3/0, and serial 3/1 as at my GNS. So I also assign the clock rate here. Next, for the last router 3, I also I already configure the interface loopback 0, loopback 8, loopback 9, loopback 10, loopback 11, loopback 20, loopback 25, loopback 30, loopback 35, and loopback 40, and the last one is I configure the interface for S3/1. So after finish configure all the command on the three routers, to verify that I can ping across the serial link. After I finish, I use the TCL script to check full and partial connectivity throughout this lab. So I already run the TCLH script command. So I show it. So this is the command TCLH. So after that, I ping for each of these IP address, and then we can see that here only few of the IP address can ping successful. So we go back to the question: which pings are successful and why? From my command here, we can see that the ping that successful is only from 172.16.11 until the here until 172.16.12.2 only. Okay, it is because all of these IP addresses are directly connected to R1 and the others are not successful because it is a remote network that R1 has not learned yet. It needs to have a configured routing protocol between all routers in order for R1 to reach all those IP addresses. Step 2. Configure EIGRP. I will configure R1 and R2 to run EIGRP in Autonomous System 1. On R1, add in all connected interfaces either with classful network commands or with wildcard mask. Use a classful network statement on R2 and disable automatic summarization. Okay, I already configure the command in the R1. I use command that use a classful network command like here, and then I already configure at the R2. Then here, next I verify the EIGRP configuration using the show IP EIGRP neighbors and show IP route EIGRP commands on R1. So like here, I already run my command in R1 here. So here is the first step. This here I configure the router EIGRP one here. Then next to show IP route EIGRP here. Show IP EIGRP neighbors here. So the address is 172.16.12.2. Okay, same. Then I configure at the R2 like here. This is the R2. So the next to verify that R1 and R2 can reach all of the network in the EIGRP routing domain using the following TCS script. So back to the R1, I already run the command to ping all the address here, and the result is all can ping successful. Step 3, manually summarize with EIGRP. To make routing updates more efficient and ultimately reduce the size of routing tables, continuous EIGRP routes can be summarized out and interfaced by using the IP summary address EIGRP as network mask interface configuration command. First, on R1, advertise one supernet route summarizing the network of loopback 48 and 49 to R2. So this is here, this is the command, and I already run the command on my R1 here. IP summary address EIGRP 1 192.168.48.0 255.255.254.0. So this is the command to advertise. Next, to verify, I use the show IP route. So the result is like here, and the result is same as the lab. Next, notice how EIGRP now has a route to the summarized address going to the null 0 interface in the routing table. So verify the specific for summarized route using the show IP route IP address and mask command on R1. So I run it too, so that show IP route here, and then the result is distance 5 and null 0, same as the lab. Notice the lower administrative distance AD for this route. Why does EIGRP add the summarized route pointing to the null 0 interface with a low AD? EIGRP add the summarized route pointing to the null 0 interface because it is the source of the summary and it has knowledge of all existing subnets advertised by the summary route. The low AD because it ensures the summary route is preferred over other routing protocols. EIGRP AD equal to 5, lowest among others. Next, will it be any different if you implement auto summarization if compared to that of manual summarization? The output will be different as we implement auto summarization. The router will receive the route to the classful network, but it is a manual summarization. The router has the classless route to reach the subnet. Next, to verify the routing table of R2 using the show IP route EIGRP command. So here is my R2. So I run the command show IP route EIGRP, and so here is our IP address 192.168.48.0 23.0/23, same as the lab. Then try to ping the IP address of 192.168.49.1, and the result is successful. The ping is successful. That's all for my explanation. Next I will continue to Ahmad Akmal.
Assalamualaikum warahmatullahi wabarakatuh. My name is Ahmad Akmal bin Azman, and now I will continue to demonstrate step 4 until step 7. Okay, for step 4, configure SPF. I would like to inform to you that I have already configured from A to E. Okay, so now let's proceed to F, which is to verify the configuration that I have made. Okay, so you can see here the neighbor for router 2 for SPF is router 3, 172.16.23.3, this IP address. Okay, this is the routing table for router 2 after I have configured the OSPF. For router 3, okay, this is the address for interface for router 2. And this is the routing table for router 3. Okay, verify that R1 and R2 can reach all of the networks in OSPF. Okay, so you can see here for R2 successfully can successfully ping all this IP address, means that the configuration that I've made for R2 for OSPF is correct. But as you can see here, R1 can only ping this first two IP address because the first two is in the R1 connected network. That's why R1 can ping these two IP address. But for the others, which is from this area, R1 cannot ping because I have configured EIGRP and OSPF, and R2 has not redistribute EIGRP into OSPF and OSPF into EIGRP. So that's why R1 cannot ping all the address for the OSPF. But actually for this question, I have referred to internet, and I noticed that it asks for R2 and R3 to check to reach all of the networks in OSPF, not R1. So let's try for R3. Yes, you can see here R2 and R3 are successful to ping all this IP address. Means that the configuration that I've made for R2 and R3 for SPF are correct. Next, step 5, to summarize for SPF areas at the area border router. Okay, review the routing 2 table. Notice the OIA for the R3 loopbacks. Okay, where can you summarize in OSPF? Okay, to summarize in OSPF, we can summarize at the ABR and ASBR. Okay, these 4 routes can be summarized into single inter area. Okay, so if you want to summarize an inter area network for SPF, we can use area and range command. So let's try. Okay, after we apply this command in R3, let's see the changes. As you can see here, it only shows 192.168.8.0/22. Means that all these three IP address is includes here. Okay, compare and contrast OSPF and EIGRP in terms of where summarization takes place. Okay, EIGRP allows summarization at any EIGRP router interface in the domain, while OSPF can summarize only at the ABR and ASBR. Next, for step 6, configure mutual redistribution between OSPF and EIGRP. So before that, I would like to inform you that I have configured all these commands. So let's proceed to C, which is to show the IP protocols in router 2. So the output here is for routing protocol EIGRP1, it's redistributing OSPF1, and for routing protocol OSPF1 in router 2, it is redistributing external routes from EIGRP1, includes subnet redistribution. Okay, next display the IP route in R1. Okay, it shows here D, which is the EIGRP, and EX external, means that all the DEX address are from the external routes, which is the OSPF. It comes from the routing table 3. So R1 here can now goes to R3 loopbacks. So next display show IP route in routing table 3. It shows here R1 loopbacks with the code OSPF external type 2, which is the default type. So all the address from R1, which is EIGRP, will be using code OSPF E2, which is from the external. Okay, next, verify full connectivity. Okay, as you can see in the output here, router table 1 can router 1 can reach all these addresses. Means that after we redistribute EIGRP into SPF and OSPF into EIGRP, router 1 managed to ping all this address. Means that router 1 has routes to all these R3 loopbacks. Okay, next proceed to last step, to summarize external routes into OSPF at the autonomous system border router. Okay, before you make any changes, display the R3, the OSPF routes in the routing table. Okay, notice the external routes for the R1 loopback interfaces 48, 50 and 51. Okay, which mask should you use to summarize all loopbacks? 1 prefix. Okay, we will use 22-bit mask with the loopback 48. Okay, next we can summarize all this all into one supernet on R2. Okay, verify the section in the R3 routing table. Okay, now as we can see here, 192.168.48.0/22. So this includes all these three network address. Okay, next for these questions, first two questions will be answered by Fahmi, and last two questions will be answered by me.
Step 7. Summarize external routes into SPF at the ASBR. In this step, I cannot summarize route distributed into a space using the area range command. This command is effective only on routes internal to the specified area. Instead, use OSPF summary address network mask command. First, before I make any changes, I display the R3, the OSPF routes in the router table and list only those routes that have a E2 type matrix. So here is the command at the R3. So show IP route OSPF include E2. So here is the IP address that I need to use. Okay. Notice the external route for the R1 loopback interfaces 48, 50 and 51. Loopback 58 and 59 were previously summarized in EIGRP that will be included when redistributing the EIGRP into OSPF. The question is, which mask should you use to summarize all loopback 48, 50 and 51 to one prefix? The answer is I use the 22-bit mask with the network address of 192.168.48.0. Next, you can summarize this all into one supernet on R2 using the following commands. So here is the commands on R2, router SPF1, summary address 192.168.48.0 255.255.252.0. Then I have to verify this session in the R3 routing table. So at the R3, I use command show IP route SPF include E2. So here is the IP address of 192.168.48.0/22. Okay, the question, what would happen if loopback 50 on R1 were to become unreachable by R2? The answer is R2 would still advertise the 22-bit summary address to R3 until all the subnets included in the summary become inaccessible. Next question, would data destined for 192.168.50.0/24 from R3 still be sent to R2? The answer is yes. Data packet destined for 192.168.50.0/24 from R3 will still be sent to R2. Okay, next question will be continued by Ahmad Akmal.
Next, for question number 3, would data destined for 192.168.50.0/24 from R2 continue to be sent to R1? The answer will be no, because router 2 has no prefix longer than 22 bits that match the subnet. The packets will be routed to the non-zero virtual interface on router 2. For last question, if you are unsure of the outcome, shut down the interface on R1. Then trace route command 192.168.50.1 from R3 and then from R2. So it shows here router 3 reach router 2 interface, but the destination is not reachable. For router 2, it cannot reach the destination, which is the 192.168.50.1. This is because we have shut down the interface, so router 2 and router 3 has no routes to reach the interface, to reach the network. So is this a desirable outcome? Yes, because summarization allows routing tables to be reduced in size, but a result which sometimes might be considered mildly undesirable is that the data traffic is forwarded beyond where it would be forwarded without summarization. So let we turn on back the interface. Okay, successful. Okay, router 2 also success. So that's all from us for this lab. Thank you.